Hello, everybody. So this is topic third from unit first of chemistry paper second in semester second. Solid state chemistry. Solid state chemistry. You know, many substances what you observe around you or surrounding to you are in the solid state. Okay, the pen you have, the mobile you have. Okay, and different things are there. Okay, the salt you eat, the sugar you eat. Okay, the mirror which you just see your reflection, and all things surrounding to you are the solid state. Okay, which you can see. So gas, liquid, and solid are the three main state of matter. Solid state differ from the other two states in that solid have definite shape, definite volume, high density, non-compressibility, rigidity, hardness, and mechanical strength. These properties are due to the existence of very strong force of attraction among the atom, ion, and the molecules of the solid. It is because of these strong forces that the structural unit of solid do not possess any translatory motion but can have only vibrational motion about their mean position. Solid state may be generally classified into two broad categories: crystalline solids and amorphous solids. Crystalline solids and amorphous solids. These are the two main types of solid. See now, what is a crystalline solid? It is a well-defined crystalline form with their atoms or molecule or ion arranged in a certain definite geometrical pattern throughout the three-dimensional network of the crystal. Throughout the three-dimensional network of the crystal. Okay. In amorphous solid, atoms or ions or the molecules are randomly arranged, and thus they lack a specific or regular arrangement of atom, ion, or molecule in the long range. So, in fact, amorphous solid can be regarded as a supercooled liquid and having small structural unit with short range order occupying fixed positions. Okay. Example of amorphous solids are the glasses, rubbers, plastic, etc. An example of crystalline solid are sulfur, sugar, sodium chloride, diamond, and many more. Okay? As you know. So we can distinguish or we can do the comparison between amorphous solid and crystalline solid. Amorphous solid. Amorphous. Morph means form. Morph means form. Amorphous means not a definite form, formless. Okay, so amorphous solid, they do not have any pattern or arrangement of atom, ion, or molecule in the three dimension. Okay, not a specific pattern. That in crystalline solid, they have perfect regular geometry due to definite and orderly arrangement of atom, ion, or molecule in three-dimensional space. Amorphous solid do not have sharp melting or boiling. Sharp melting. Okay, they get softened on heating and then they start flowing without undergoing any sharp solid to liquid state. While crystalline solids have very sharp melting point and they convert from solid state to liquid state very abruptly. Amorphous solids are the isotropic, means they shows their physical properties similar from all the directions. Okay, crystalline solids are anisotropic, means their physical properties are not same along all the directions. Right? So amorphous solids do not have well-defined plan. Amorphous solids do not have well-defined plan. Okay, when an amorphous solid is cut with sharp edge tool, and irregular fracture is often. Crystals are bound by the planes. When crystalline solid is cut with sharp edge tool, it is readily cut into smaller crystal. Amorphous solids do not have symmetry, while crystalline solids have symmetry. Amorphous solids are considered as a supercooling, or they may be called as a pseudo-solid. But crystalline solids are considered to be true solids. Amorphous solids are not very rigid. They can be distorted by bending or compressing forces. Crystalline solids are rigid and their shape is not distorted by mild distorting forces. A few examples of amorphous solid are glass, rubber, plastic, etc. Diamond here in crystallized solid, diamond, quartz, and salt is there that we eat in every day-to-day life. Calcite and other examples are there. Now we'll see what is isotropy, what is anisotropy. Okay, so amorphous substances are said to be isotropic because they exhibit same magnitude of any physical property measured in any direction. If we measure a physical property in this direction, okay, or in this direction, for the anisotropic solid, okay, sorry, for the isotropic solid, the property will remain same. Property will remain same. In case of anisotropic solid, property will vary from direction to direction. Okay, and hence this is what the very basic and big difference between isotropic and anisotropic ones. Okay, so amorphous substances, as in liquid, the arrangement of particle is random and is distorted. Okay, therefore all directions are equivalent and have properties independent of the direction to be measured. Okay, so this is how the isotropic substance is. Now, what is the concept of space lattice and unit lattice? Okay, we'll see the concept of space lattice and unit lattice. Okay, in crystal, the atoms are arranged in a highly ordered and regular manner. Each atom has a definite place in the crystal and is equidistant from its neighboring atom. Okay, in crystal, the atoms are arranged in a highly ordered manner and regular manner. Each atom has a definite place in the crystal is equidistant from the neighboring atom. Each atom has the same surrounding as any other atom in the crystal. The most elementary arrangement of atom in the crystal is called a unit cell. Okay, if you see in the in the diagram, this you can call as a unit cell. And if such a number of unit cells come together, they form a space lattice. They form a space lattice. Okay, they form a space lattice. Okay, and the point of intersection of a line is called a lattice point. Point of intersection of the lines is called lattice point. This is called lattice point. Okay, so a unit cell can thus be regarded as a basic building block of crystal system. Repetition of this unit cell in a crystal results in the regular spacing of the atom called a space lattice. This whole system you can call as a space lattice. आणि ही बेसिक युनिट आहे. वीट असतं माहिती आपण ब्रिक इमारत बांधण्यासाठी एक वीट लावली तर तिला आपण युनिट सेल म्हणूयात आणि त्या विटा जर अशा एक 200-400 विटा एकत्र ठेवल्या आपण ना किंवा यू आर कीपिंग thousands of bricks at a place, so that all the bricks are called a space lattice, but a single brick is called a unit lattice. Okay, so in the space lattice, atoms are arranged in orderly manner in a plane called a lattice plane. Okay, that the plane is called lattice plane, and that is very important for the further study. Okay, now see unit cell. As I told you, the smallest unit of a space lattice, which is repeated over and over again, result in a crystal formation that is called unit cell. And such a large number of unit cell come together to form a space lattice. Okay, that unit cell is having it's a characteristic like a length of its edges, length of its edges, that is shown as a small ABC. Okay, along the three coordinate axes like OX, OY, and OZ. Okay, the angle between the edges are considered that uh, written as alpha, beta, and gamma. Alpha, beta, and gamma along x, y, and z axis. If you see here, see this is what A, here it is B, and here it is C. Okay, and the angle, this is alpha angle, this is beta angle, and this is gamma angle. Okay, these three angles are there. You can see in the diagram itself. And these are the axes. See now, OX, this is OX, OY, this is OZ. Now, laws of crystallography. So, which is a branch of science. Crystallography is the branch of science which deals with the geometry, property, and structure of crystal and crystalline substances. It deals with the geometry, properties, and the structure of crystals and crystalline substances called crystallography. Okay, so what is first law of crystallography? Or it is also called as a law of constancy of interfacial angle. According to Neil Stenson, the angle of intersection of any two corresponding faces would always remain constant. Would always remain constant under any condition of crystal formation. Under any condition of crystal formation. Okay, even though there may be the impurities, stirring, and other factors are there. Okay, but the angle of intersection of any two corresponding faces will always remain constant. That is the what angle? Alpha, beta, gamma, or you can say the theta. Okay, so according to law of constancy of interfacial angle, the shape and size of a crystal of a certain compound or element may vary with the condition under which the crystallization is occurred. The angle between corresponding faces will always remain constant. Will always remain constant. Okay. See, for example, this is a crystal of NaCl crystallized in cubic form from an aqueous solution, and it is an octahedral form from an aqueous solution containing some urea and tree-like shape if some amount of gum arabic is present. But if you see in all three diagrams, the angle theta is remain constant. Is remain constant. Okay, so this is what the law of constancy of interfacial angle. Now, some laws are there. Okay, second law is a law of symmetry. Second law is a law of symmetry. So, in the law of symmetry, there are three symmetries. One is plane of symmetry, plane of symmetry. Second is axis of symmetry, and third one is a center of symmetry. Now, if you cut, see, these are what the cubic structure. These are what the cubic structure. Okay, if you cut this cube along any direction, see here, this is one plane. Okay, this is another plane, vertical. This is vertical plane. This is see. Now this is a diagonal plane. Okay, if you cut that cube, so that shows a symmetry. That shows a symmetry. Okay, hence that is a plane of symmetry. So plane of symmetry is an imaginary plane passing through crystal and dividing it into two parts such that one part is exact mirror image of other part. Okay, plane of symmetry are of two kinds. One is a rectangular plane and other is a diagonal plane. Okay, here in diagram you can see the last one is a diagonal plane. Okay, so such a two planes are there. But when we put a plane that make two equal part of that shape or that crystal, okay, or that structure. Hence, we call it as a plane of symmetry. Okay. The next concept is a axis of symmetry. Axis of symmetry. See here, it is an imaginary line See now this, if you put axis over here, and sorry, this is axis, okay, which is already shown. Okay, this is axis, and if you rotate this, so what happens after each rotation, you will get the similar image or a similar kind of structure. Okay, so this if see, this is the axis, this is the diad axis, this is the diad axis. Why it is diad axis? Because for two times, when you rotate for one time, you will get same structure. If you rotate second time, you will get the same structure. Now this is a triad axis. So here for three times you will observe the same kind of structure. ह्याच्यातून ह्या क्यूब मधून हे टाकला ऍक्सिस, आणि तुम्ही पहिल्यांदा रोटेट केला तसंच दिसेल, दुसऱ्यांदा केला तसंच दिसेल, तिसऱ्यांदा केला तसंच दिसेल, पण चौथ्या वेळेस पुन्हा तुम्ही ओरिजिनल पोझिशनला त्या ठिकाणी जाता. म्हणून हा फक्त ट्रायड ऍक्सिस बोललेला आहे. इथे काय, you will get the same structure at two times only. For the third time, you will get the final structure again, from where you started to rotate the cube. Okay, here in this case tetrad axis. सेम स्ट्रक्चर येण्यासाठी तुम्हाला किती, एक पूर्ण रोटेशन होण्यासाठी किंवा पूर्ण रोटेशन होताना तुम्हाला 4 वेळेस असं स्ट्रक्चर दिसेल. ओके, हेन्स इट इज कॉल्ड टेट्राड ऍक्सिस. इट इज कॉल्ड टेट्राड ऍक्सिस. ओके, or tetrad means fourfold, triad means twofold axis, triad means threefold axis. Okay, this is hexad means sixfold axis. That sixfold axis is also there, that you can observe in this shape. Okay, hexad axis, you will get same structure for 6 times. This is the axis. If you rotate along this axis, you will get the hexad structure. Okay, hexad axis is there. Okay, and you will get 6 times same structure, hence the hexad axis. So axis of symmetry is an imaginary line about which the crystal is rotated so that the crystal presents the same appearance more than once in the course of complete revolution, complete rotation by an angle 360. Okay, if same appearance repeating after 180 degree, that is called twofold axis. If same structure appears for 3 times, okay, so that is called threefold axis or triad. If same structure appears for 6 times, that is called hexad axis. But provided that you need to observe the same structure till you rotate about 360 डिग्री, म्हणजे 360 डिग्री रोटेट करताना किती वेळेस सेम स्ट्रक्चर दिसलं ना, 360 ने रोटेट करताना तुम्हाला किती वेळेस सेम स्ट्रक्चर दिसलं, तो ऍक्सिस असणार आहे. 6 वेळेस दिसलं म्हणून हेक्झॅड ऍक्सिस, 2 वेळेस दिसलं म्हणून डायड ऍक्सिस, 3 वेळेस दिसलं तर ट्रायड ऍक्सिस. हियर इन दिस केस you will get the 4 times same structure, hence it is called tetrad axis. Okay, now, and the last one is a center of symmetry. This was center of symmetry. या सेंटरच्या ह्या साइडला बघितलं आणि त्या साइडला बघितलं तरी तसं स्ट्रक्चर दिसतं, ह्या साइडला बघितलं त्या साइडला बघितलं तर सेम आयटम असतो, तर त्याला सेंटर ऑफ सिमेट्री म्हणतात. ओके, तर त्याला काय म्हणतात, सेंटर ऑफ सिमेट्री. So it is an imaginary point in the crystal, okay, such that any line drawn through it will intersect the surface of the crystal at equal distance in both directions. Okay, it is an imaginary point in a crystal such that any line drawn through it will intersect the surface of a crystal at an equal distance in both directions. A crystal is said to have a center of symmetry if every face of the crystal has an identical face at an equal distance or on the opposite side of this center. A cubic crystal has only one center of symmetry. Cubic crystal has only one center of symmetry. Here you can see, here is only one center of symmetry. ह्या डायरेक्शनला जेवढे जातात तेवढेच त्या डायरेक्शनला जर गेला तर इंटरसेक्ट होईल. ओके, म्हणून तिथे वन सेंटर ऑफ सिमेट्री आहे. ओके, सो the next point is the law of rationality of indices. Law of rationality of indices. Okay, so law of rationality of indices I will explain in the next lecture. Okay, thank you.